We'll come to the first question today. As this. Take the first question today as these people. It is integration of e to the power ax cos bx dx. Right? This is the first question today. Eax cos bx dx. Right. By parts formula, you know, by parts formula is integration u times dv by dx dx equals uv minus v times du by dx dx. Right. So then this function, I take this answer as people I. Let this answer be I. We take it as I. Eax cos bx dx. Then I'm going to take this e to the power ax as u, and our dv by dx as cos bx. Cos bx, right? Now this u function we have to always differentiate, people. We know this u function should be differentiated to find du by dx. Eax into derivative of ax is a, then this into a. And this dv by dx function cos bx, we have to integrate to find what this v. Sin bx divided by b. Okay. Now the integral of this, that is I, know, and then we can write I apply here uv, u into v. U is this eax, v is this. Then we get eax sin bx divided by b. So v minus v sin bx by b du by dx, aeax dx. Now this a and b are constants, take that out. Then we get I is equal to eax sin bx divided by b. Take this out. A upon b eax sin bx dx. People will take this as equation number 1, right? With this integral as j. Let this be j. Or else we can write that separate like this. I can then write it like this. I is equal to eax sin bx divided by b minus a divided by b times j. This is number 1, where j is equal to integral e ax sin bx dx. Okay. Now to evaluate this j, to find this j, we again apply by parts for this. Then there we take this E as our u, and our dv by dx is this sin vx. You know, u function we have to always differentiate, and dv by dx function, this one we have to integrate to find this v. Right. So then we get du by dx is equal to EAX, derivative is EAX into A. When you integrate this to find V, integral of sine means people minus cos Vx divided by V. Now we substitute to find this J, we are in the by parts formula, right? So therefore J, we can write U into V. U is this, V is this, minus cos Bx divided by B. U into V minus V du by dx. A E Ax dx. Right. Now here this minus sign, A and B we can take out. K equals minus EAX cos Bx divided by B, minus we can take out, then we get A upon B with plus sign now. EAX cos Bx come in. Dx, right? People now EAX, integral of EAX cos Bx means it is really again the same I. Again the very first the given question come in to integrate. Then we don't integrate that again, we put that as I. This is how I. Then we can write, I write that here. Therefore, we can write J is equal to minus EAX cos Bx divided by B plus A upon B times I. This is I. Now this J available in number 1 here. For this J, we substitute the answer. Substitute in number 1, I is equal to EAX sin Bx divided by, EAX sin Bx by B minus A by B. This is the I know. For this J now I substitute by this answer. It is minus EAX cos Bx divided by B plus A upon B times I. Right? Now we remove the bracket by multiplying this way, and this I we can take this left hand side. Then we get I multiply this 2 and bring this to this side, plus a squared divided by b squared times I is equal to here EAX sin bx divided by b, minus and minus make plus people, a b and b squared EAX times cos bx. Right. Now we have to subject people this I. Take this I out and take this b squared as common denominator. Then this is a squared plus b squared divided by b squared. Right. On the right hand side, we can take this EAX divided by b squared out, people. Right. Then here we don't have b squared. Then this should be multiplied by b. There it is b sin bx, and here EAX divided by b squared, when we take out, we get a times cos bx. Now this b squared we can cancel down this b squared. Then we can subject this I dividing by a squared plus b squared. Understand? Then we can get the answer of I. I was the given question, integral of EAX cos bx dx. Then you can take the answer by adding a constant to the right hand side. Understood? Right? Okay. Therefore, I can write I. It is EAX should be divided by this. A cos bx, I write like that, plus b sin bx. Right. So then, what is this I? I is that EAX cos bx, no? Therefore, you can take the final answer. Right. Hence, we can take the answer EAX cos bx dx is therefore EAX divided by a squared plus b squared times a cos bx plus b sin bx plus k. Write down k is any constant. This is how we take the final answer. Right. Okay, right. We'll come another one question, people. Right, shall I erase this here? Next one is integral of x squared times sin inverse x dx. Right, take this, people. I'll give 2-3 minutes. Right, now here we can take, people, this as your u. And this as your dv by dx. The reason is, if we take this as our dv by dx, then to find v, we have to integrate this sin inverse x. No? directly we don't know the integral of sin inverse x, but we can find that again taking the sin inverse x alone and applying by parts method. Last week we did that one. That means we found the integral of sin inverse x. Right. So therefore there are two questions in it. No, first for sin inverse x, and then we select this other way. Right. So then this is nothing but now x cubed by 3, right? And this is now du by dx. It is 1 upon square root of 1 minus x squared. Now we apply by parts formula. This way, x squared times sin inverse x, right? Equals u into v, uv, x cube times sin inverse x divided by 3 minus v, du by dx is this. Dx. Right, now I can take this 3 out, and you can write that as 1/3 x cube divided by 1 minus x squared dx. Right, people? And here we have this. Okay, I'll take this one, people, as I. This one I'm going to take as I, because in a separate place, separately we can integrate that and finally to substitute the place that answer. Otherwise, if we keep doing the same steps, people, everything this we have tried with each step, no? So unnecessary workings they are coming, right? Then x squared sin inverse x dx. And then we can write that this way, x squared into sin inverse x dx, x cube into sin inverse x by 3. This is now I know. Minus 1/3 times I, number 1. I take separately like this. I equals integration of x cube divided by square root of 1 minus x squared dx. Right, now how to do this integration? Well, this one I can do in this way. I equals x cube, I'm going to write as x into x squared. Okay, here we write x squared. And now I write here minus x and minus x squared. Minus minus plus. X and x squared is x cube, we get. Now this minus x squared, I write like this. and I am writing here 1, and I subtract another 1. Right now, what happens? 1 minus 1 we can cancel down. It's minus 6 into minus x squared, minus plus x into x squared is x cubed. This is coming. Right. Now, the next step is I equals, now taking this term separately, I can divide this 1 minus x squared separately by this 1 minus x squared root. Then to the numerator we get 1 minus x squared power 1 divided by 1 minus x squared power half. This and this when you divide, people we get 1 minus x squared power half to the numerator, that means square root. And there we get this minus sign I can take out. All right, we'll keep that inside there. Minus x times 1 minus x squared power half. Right? And this minus make plus. Plus x upon this. One minus x squared. This is what we get finally. Dx. I think up to there you can very easily understand. Right now, people? Yeah. Then what we do next is this. I'm going to use this technique of integrating what? People, can you remember? We did something like this. Fx whole thing to the power n times f dash x. Integration dx. Here f dash x we have. You know the integral of this, people. What is that? Fx to the power n plus 1 divided by n plus 1. Using that technique only, I am going to take the answers. That means in this part, I am going to take this as our fx. 1 minus x squared our fx. N is this half over there, n is here half. The derivative of this 1 minus x squared, if we have here, that answer we can apply. Then the derivative of this part is minus 2x. But here we have minus x. Then what I do is, this one we multiply by 2 and divide by 2. Like this. Then that will, dividing by 2 will be half. Integration minus 2x. 1 minus x squared to the power half dx. Correct, no? Now I take this square root to numerator. That will be, this is power half, no? Also take that to numerator minus half. Then we have x 1 minus x squared to the power minus half. For this also, people, we can apply the same technique. That one, if we have here derivative of this, here 1 minus x squared derivative is minus 2x, no? Then I multiply this by minus, right? 2x. Minus 2x I write here. And divide this by 2. This minus and this minus make people plus this one. 2 and 2 we can cancel down. We get x, this one, and this. That is this. So now I arrange that also this way now. Minus half integration minus 2x. Here, dx. Understood. Now you can see for this and this, you can apply this result. Understood, people? Then we can take that answer. How? I is equal to half, yeah, take 1 minus x squared, add 1 here. Half plus 1 is 1 and half, 3 by 2. Then 1 minus x squared to the power 3 by 2 divided by 3 by 2. That is 2 by 3, right? Minus half here, add 1, minus half plus 1 is for people plus half, right? 1 minus x squared plus half divided by plus half. That means multiplying by 2, no? Dividing by half means multiplying by 2, no? This is the answer we get. We can furthermore simplify this. This and this we can cancel down. This and this we can cancel down. Then the answer of I we get like this. Therefore, I is equal to what, people? 1/3 1 minus x squared to the power 3 by 2 minus x squared to the power half, right? Now this we substitute in number 1. So then we get by number 1 the required answer. Substitute for I in number 1. Therefore, by number 1, x squared sine inverse x dx divided by 3 minus 1/3 I. I is this one, that no, people. 1/3 1 minus x squared to the power 3 by 2 minus 1 minus x squared to the power half. Multiply by this, then we get the answer. One upon 9, 1 minus x squared 3 by 2 minus make plus, people, 1/3 1 minus x squared to the power half plus k. K is any constant. K is any constant. This is how, people, we integrate that. Right. People, shall we take another one more? It is this. X sine inverse x. The next one, x sine inverse x. We consider here x squared sine inverse x. X sine inverse x. This one was in a past paper, some x sine inverse x, right? Try to get this, people. X sine inverse x. X sine inverse x. Right, we'll see how to take that. X sine inverse x. Right. There are also, people, this sine inverse x we take as u. And we take this dv by dx as this x. Then u function we differentiate 1 upon square root 1 minus x squared. V is x squared by 2, right? Now, integral of x sine inverse x, we can write uv. V is this x squared by 2 sine inverse x minus v integration v du by dx. This is, can we get x squared times sine inverse x divided by 2. Here we can take this 2 out, and I bring this minus sign in, then we get plus half minus x squared. We take this minus sign inside, right? This way. Dx. And here we add 1 and subtract 1. Okay. X squared sine inverse 6 by 2 plus, right, half, add 1 and subtract 1, like this. This way. X sine inverse x dx, x squared sine inverse x by 2. Right. Now we divide people this one by this. 1 minus x squared divided by its root means 1 minus x squared root minus 1 upon this. We get dx like this. Huh? Okay, now people, we can integrate this and this separately. X sine inverse x dx is equal to x squared sine inverse x by 2 plus half times this one, integral of this with respect to x, and this half, this minus sign we have, minus half, therefore 1 over square root of 1 minus x squared. Dx. People, I am going to take this as I. The integral of this is what, people? It is 1 upon square root of 1 minus x squared is sine inverse x. Okay, and then I can write this answer. Integral of x sine inverse x is equal to here x squared sine inverse x divided by 2 plus this is, people, I, therefore this is half I. and minus half. Integral of this is people sine inverse 6, right? Sine inverse 6. Let this be number 1. Now its I we have to find. Its I we have to find. When you find its I is equal to people that root 1 minus x squared. Like this. Now can somebody tell me how to integrate this root of 1 minus x squared? There people? For that again we apply by parts. Yeah. For that we apply by parts. For what? For this. How to apply that? This one you take as u. And this one we can think as 1 multiplied by this, no? That 1 we take as dv by dx. Then keep doing this, people. I think you get this answer. Right. Okay. Right. Now, people, here, when I differentiate this u, du by dx, people, how to differentiate the square root? It is 1 over 2 times this. Multiplied by, now we differentiated the square root, power half. Thereafter, that should be multiplied by the derivative of this, no? We know under differentiation lesson we learned derivative of this square root is what? 1 over 2 times the same multiplied by derivative within root sign. It's 1 minus 2x this. And here v is x. When you integrate 1, it's x. You can cancel down this and this. Du by dx, people, it's minus x upon square root of 1 minus x squared. Right, no? 2 and 2 we can cancel down. This we get, right. Now this I we can evaluate. Applying by parts formula, u into v, right? U is square root of 1 minus x squared. V is x. I write like this. Minus integral of v. Du by dx is that. Minus x upon square root of 1 minus x squared dx. Now what we do, people, here? I x times 1 minus x squared. Here we have minus x squared, no? That we can write 1 minus x squared minus 1 divided by this. I added 1, subtracted 1. Then 1 and minus 1 we can cancel down. Minus x squared, x and x. Here minus x squared we get. Then what we do is this 1 minus x squared part we divide by this. Here 1 minus x squared root no power half. Here power 1. When you divide them, we get power half to the numerator. This way. Minus this divided by this means integration root 1 minus x squared dx. And this minus make plus. 1 over square root of 1 minus x squared dx. People, what is this? Again, we get this here. I equals x times this. Minus this is I. Plus, what is this, people? Integral of this is sine inverse x, no? Sine inverse x. Bring this minus side to this side. 2i, no? Okay, then you can subject this I. That I, people, we can put where? Here. Okay, no? Right. Then we get the answer. Right. Then I can be subjected by this half x times square root of 1 minus x squared plus sine inverse x. Now by number 1 you can write. Now by number 1, this one is number 1, x sine inverse x dx equals x squared sine inverse x by 2 plus I this. Then here we have half I, know. Then we get 1 upon 4 because this half and this half we can multiply 1 upon 4 x times 1 minus x squared root plus sine inverse x minus half sine inverse x. Yeah, now we can furthermore simplify this. X squared sine inverse x by 2. Here x by 4 square root of 1 minus x squared. Here people 1 upon 4 sine inverse x minus this. Then we get minus sine inverse x by 4, no? Plus k. K is any constant. K is any constant. This is how we take the terms. Right now? Yeah. This is how people we take that answer. Yeah. Now next one, this people. Next one is people this. Take the next question. Integration of sin ln x plus cos ln x dx. Sin ln x plus cos ln x dx. I take this one, people. මේ ගන්න ළමයි. Sin ln x plus cos ln x dx. I'll take this one, people, first. Integration of sin ln x I take. I take, now I can separate this now. What? Integration of this and integration of this. Its first integration I am going to consider. Sin ln x. So now I am going to apply by parts like this. This one I am going to think as 1 into this. Then this part I am going to take as u. U sin ln x, and this 1 we consider as dv by dx. Right. You know, people, this dv by dx function we have to integrate now. When we integrate this 1, we get v. Integral of 1 is x. And this u we have to differentiate. U function we always differentiate. Du by dx. Sin means cos ln x. All right. We first differentiated sin. Now that should be multiplied by the derivative of ln x. It is 1 upon x. This is what we get for du by dx. Then by using this, by parts formula, sin ln x, we can write as u into v. U is sin ln x, v is x. X times sin ln x. uv minus v x, and du by dx, people, cos ln x into 1 upon x dx. You can cancel down this and this. You can bring this, people, to this left hand side. Then what do you have? Sin ln x dx plus cos ln x dx is equal to x into sin ln x. Now, people, this integration, this sum I can write as adding these integrands together and write in under one integration like this. This here, this left hand side we can write. It is nothing but the given question, no, people, here. So then its answer is this: x sin ln x plus k. K is any constant. K is any constant. This is how, people, we take that. Okay, no? Right. Okay, now we'll move to the next part. Right now, we come to the next type. People, what is the type number? Type number 6, no? Type 6. Under this type 6, people, we are supposed to integrate this type of integrands, right? 1 upon square root of x squared minus a squared dx. See here, denominator we have a square root, right? And another form we supposed to consider there, that is 1 upon square root of x squared plus a squared. The third type is, people, 1 upon square root of a squared minus x squared dx. Right, people? These are the integrands we supposed to consider under this type. People, this is a special case. We are going to integrate this each using a substitution. This is the first time that you are going to use the substitution method. Usually we use a substitution, people, in order to make easier the integration process. That is the main idea of using the substitution, right? Then here, people, when we integrate this, the substitution we use is x equals a sec theta. Here the substitution is x equals a tan theta. Here we know actually this is really sin inverse x upon a, no? Here we use x equals a sin theta. These are the substitutions. I'll explain one by one how do we use this substitution to integrate process. Okay, write down type 6 like this. This type is this, then the substitution is what? I write here substitution, right? Substitution. For this one, x equals a sec theta. This one, x equals a tan theta. This one, x equals a sin theta. We'll take one by one. Okay, first one I'm going to take, people, this. Is 1 over square root of x squared minus a squared dx. The substitution is, people, x equals a sec theta, no? Right. Whenever you use the substitution, our first step is, people, this substitution you have to differentiate. Now this x is a function of theta, no? Then we can differentiate this x with respect to theta, thereby we can find dx by d theta. Okay, then we get dx by d theta. A is a constant. Derivative of sec theta is, people, sec theta tan theta. Sec x derivative, you know, derivative of sec x is, people, sec x tan x. All right, here we have theta, no? Then sec theta tan theta. Then subject this dx, because for this dx we are going to substitute in terms of theta. People, here what we do is the original variable given us is x, but the integration is done subject to the new variable theta. So therefore every x is available this integrand, and that dx we have to replace in terms of theta. So that is why we differentiate this to find this dx. Therefore subject dx by this. It is now a sec theta tan theta d theta, right? Now, okay, now what we do is this. We start from this. I write that pair here. 1 upon square root of x squared minus a squared dx. Right. For this dx, we can put here a sec theta tan theta d theta. d theta. Now, for this x, we substitute take a sec theta of x squared minus a squared. See here, no x letter available. Now this a squared and here a squared, we can take out from the root sign, that is a. That a and this a we can cancel down. Then finally, simple a letter will disappear from the denominator and numerator both. Here we have 1 now. Now what we have is people here sec theta tan theta divided by here what you have is sec square theta minus 1 d theta. People, you know sec square theta is what? Sec square theta minus 1 is tan square theta. Sec square theta minus 1 is tan square theta. Its root is tan theta. Right now, 1 plus tan square theta is sec square theta. They want to take this one to right hand side. Tan square theta is equal to sec square theta. Therefore, this is tan square theta within the root sign. Tan square theta. Its root is tan theta. That tan theta and this tan theta we can cancel down like this. Sec theta d theta. Understood? People, you know what are the derivative integral of sec x? Integral of sec x we wrote as what, people? Ln modulus sec x plus tan x, no? So therefore, here also we can write using that Ln modulus sec theta plus tan theta. We have to add a constant. But people, final answer, now we don't keep in terms of theta. Final answer, we have to put in terms of x because our original question was in terms of x. Yeah. Now to convert this sec and tan to x, we can use this substitution again. Right. So then the left hand side we have what? This, no? Right. This, no? The left hand side we have. Right. Okay. Now what I do is this next. Our substitution is x equals a sec theta, no? Then we can subject this sec theta x upon a. This gives us cos theta a by x. Now draw a triangle for this. Cos theta. Here theta, cos means adjacent by the hypotenuse, no? Then opposite you can find x squared minus a squared root, square root of x squared minus a squared. Then by this you can find people tan theta. Now, tan theta is opposite divided by the adjacent. Yes. This is tan theta. Then you can put that way here and here. Right? Then we can write it like this now. Therefore, 1 over square root of x squared minus a squared dx is equal to Ln modulus this one, sec theta. Sec theta is people x upon a. And tan theta is this square root of x squared minus a squared divided by a. This is what we have. Furthermore, people, we can simplify this until getting another simple answer. This one we can write the denominators are equal, no? This way we can write. Right. People, now you know Under logarithm, we have one result, no? Yeah, what is that result? Log m upon n. You can write how, people? Log m minus log n, the base suppose a. Using that, I can write this division as a difference of log ln modulus of this, right? Minus ln a. Now, people, another constant we have to add finally, no? Another constant we have to add finally. We haven't added a constant, no? That constant, when we add here as c, people, this a is a constant, no? Then ln a also another constant. Constant means real number. Then the constant we are supposed to add, and this constant, when you simplify together, we get as a result another constant. Okay. Now then, people, I am going to write here k. What is k? It is the constant we add. End of every integration we have to add the constant. That constant is here k. K is any constant, right? K is any constant. But people, this is a real number. Constant means a real number, no? This is a real number. This is also a real number. When you simplify these two, we get another real number. That also, people, since this k is any constant, after simplifying with this k, this part, the resulting answer is another constant that is not a fixed one. It is any constant. So therefore, the sum, algebraic sum of these two, we write as a what, people? Another constant c plus c. What is c? C is any constant. C is any constant. So therefore, people, this is the answer of this. This result is a standard result, people. This result is a standard result, right? Directly you can use that. But people, you should be able to take this answer using that substitution x equals a sec theta. Understand? X equals a sec theta. Right now? Were you able to take down the notes? Yeah, up to here. Now you have to take. Right? Best thing is, people, with me, you have to do. Right now? Okay, now, can you take in the same way the second answer? Second is what? Second is 1 upon x squared plus a squared. This one is the second one. What is the substitution here? We said x equals a tan theta. All right. For this now, try to get the answer. Those who finish the first one, come to this, and the same we do. Right now? Right now, here, first differentiate this. Dx by d theta, a is a constant, keep as the same. Tan theta derivative is sec squared theta. Then subject dx using the cross multiplication to this end. Dx equals a sec squared theta d theta. Right now, you can start from here. One over the 6 a squared tan squared theta plus a squared, and this dx is x squared theta d theta. Here this a square we can take out from the root sign, that will be a, that a and this a you can cancel down, here 1, here. Then this a and this we can cancel down, right? In the numerator we have sec square theta d theta. Denominator we have 1 plus tan square theta. 1 plus tan square theta is sec square theta. But people, that is inside the root sign, no? Therefore, it is sec theta. Of taking the root of that. Then 1 sec theta you can cancel down. Now we have integral of sec theta. You know the integral of sec theta is what, people? Ln modulus sec theta plus tan theta. Right. Now this theta we have to change to what? Original x. Right. So then that can be done by using this substitution. Right. But we can say what? Tan theta is equal to x upon a. We can draw a triangle for this. Theta opposite x adjacent a. Then this is by using the Pythagoras theorem, a square plus x square. Right. Now you can substitute that here. Therefore, integral of 1 upon square root of x squared plus a squared dx is equal to sec theta. Because sec theta means 1 over cos theta, no? Cos theta is this divided by this. Right. So then sec theta, you can take that answer. And then we can keep the final answer. Right. Tan theta is x upon a. Then here, what is cos theta, people? Adjacent divided by the hypotenuse. Then sec theta is hypotenuse divided by the adjacent. This way. Yeah. Then you can put that there. Ln modulus sec theta is this. Divided by a tan theta x upon a. As before, people, we can write this one this way. Divided by a. This one you can write as a difference, no? Minus ln a. And now we have to add another constant, no? That constant is any constant, right? So once we add that, plus k, k is any constant. Okay, people. Now when you add this and this simplify, we get another constant. Let us take that as c, and therefore we get 1 over square root of x squared plus a squared dx is therefore this answer. Ln modulus this plus c. C is any constant. C is any constant. This is how we people get that answer. Right. You will take the third one. What is the third one? Right. That answer we know already, but we use that substitution. Right. Use that substitution. Third one is integration of 1 upon square root of a squared minus x squared dx. What is substitution here? X equals a sine theta. Right. First, differentiate the substitution and find dx. Where's the x? Yeah, that's correct. Here, yeah, should be another x, no? This x should be here, no? I take next one, people. Right now, here, people, you can write dx upon d theta. It's a cos theta. Dx equals a cos theta times d theta. Right. Now we can substitute that here. A squared minus x squared dx. 1 upon square root of a squared minus x means, people, a sine theta. It's perfect squared because we have x squared, a squared, and then sine squared theta. Dx is, people, a cos theta d theta. This a squared is common. Once you take it out from the root sign, that will be a. That a and this a we can cancel down. Then finally, all these simple letters will vanish. Now, given here, what, people, numerator cos theta d theta, and denominator, what do we have? Square root of 1 minus sine squared theta. 1 minus sine square theta is, people, cos squared theta. Its root is cos theta. Cos theta and this we can cancel down like this. We have 1 d theta. Integral of 1 with respect to x is, people, x. But here we have integral of 1 with respect to theta. Therefore, this answer is theta. You know, here, integral of 1 with respect to x. Whenever we have this letter x, this is x. 1 d theta is, therefore, people, should be what? Theta. Theta. This is theta. But what is, people, this theta? Yeah, but x equals a sine theta, no? Then subject sine theta, x upon a. Then subject theta, take the sine inverse. Theta equals sine inverse x upon a. Then answer of this is sine inverse x upon a. We know that already, people, but using the substitution, this is how we take that. Therefore, we can write 1 upon square root a squared minus x squared dx is sine inverse x upon a plus c. C is any constant. That's how we take that answer, right? Right. Here will come the next type. Next type, right? Type 7, no? Type 7. Right. Under this type 7, people, we are supposed to discuss this type of integrands, right? We have a function fx, right, having its power something here in suppose, and it is integrated not with respect to x, with respect to fx. This kind of thing, right? With respect to fx. This type. Okay? This type. This type, right? This. Here, remember fx to the power n, it is integrated with respect to the function fx, not x. This is another important one, people, when you take the answers. There are some questions, if you know this theory, very easily you can take the answer. Right, minimizing many steps, right? Now, for example, I can take something like this. Now, suppose we have integration of sine to the power 5x cos x dx. We are given something like this. Then, if I try to apply this way to get this answer, I do like this. People, I differentiate this sin x with respect to x. The root of sin x, you know, people, cos x. Then we use the cross multiplication. D sin x equals cos x dx. But here you have, people, cos x dx. For this cos x dx, now I can put d sin x. Now we can write this one. Integral of sin to the power 5x cos x dx is equal to sin to the power 5x cos x dx is d sin x. Now see, people, this form we have. Our fx is this sin x. Its power n is here 5. And different integration is done relative to fx. The same function here we have. Correct? No? Same function here we have. People, now for a while, if we think this sin x as that sin x available here and here, if we assume as, people, capital X, I can rewrite that. How? Sin to the power 5 x d sin x. I can rewrite, people, sin x means capital X, no, capital X to the power 5 d capital X, like this. I can write that. Here you can integrate this. How, people? Adding 1 to this power and divided by new power. So then what do you get? X to the power 6 divided by 6. Like that, people. This one now you can integrate. How? Add 1 to this power and divide by the new power. Right? Then sin to the power this, how we take using this theory part. Understood, people? Right? Take that, people. Actually, this one, if you need, you can write at the side now. That's how we use this theory. Right, people? Shall we take another one question? Any doubt here? People, how do you feel about this lesson? Is it difficult? Huh? Yeah. Right? Little difficult. People, if you're supposed to continue this lesson with me, the message is, people, now you have passed the difficult places in this lesson. You have passed. And the only thing is, so far the theories we have learned at the beginning, remember till the end of this lesson. Then I know to guide you towards the highest. That fundamental things, people, that we learn 28 formula, right? So still you are working the questions using those fundamental theories plus new techniques. Are this all, people? The difficult places we have already passed. All right, people. Now at the moment, if you can manage, that's a good sign. Do the same questions again and again. I didn't give you the tutorial yet. The reason is this. Why? Then you try the questions in the tutorial. If you can't take the answers, you get upset. Then you get unnecessary message to the mind. What? This is confusing or difficult. At the moment, do the questions I have done in the class. Practice that again and again. Next day, I give you the tutorial. Right. We'll take another one, people. It is this. Cos to the power of 5x dx is the next. Using this theory, you can do that very easily. Among that 28 forms, people, this integral of cos to the power of 5x we don't have. But using this theory, we can very easily integrate this. But people, this is what I do. Take this next one as the next question. This one as the next question. Right. We take derivative of sin x. I take again. It is cos x. Then d sin x is cos x dx. Right now, using cross multiplication this way. Now, this one I'm going to write cos to the power of 5x dx. Now I can write, people, this way. Cos to the power of 4x cos x dx. This way I can write. Correct? No? Here power 1, here power 4. This we get. For this cos x dx, now I can write, people, d sin x. I can write d sin x. Okay. But you know, this cos to the power of 4x I can write cos squared x to the power 2 like this. D sin x. But this cos squared x I can write as 1 minus sin squared x. D sin x. Now you people, you can expand this. What is the expansion of this? 1 squared is 1 minus 2 times this into this sin squared x plus sin to the power 4x. This say d sin x. Now you have to integrate one by one. If it's a little bit confusing to think, Mentally substitute for this sin x, capital X, here and here. Then what do we have here? Integral 1 d capital X. Integral of 1 with respect to x is people x, no? Then here, since this sin x is capital X, integral of 1 with respect to capital X. What is that? Capital X. But what is our capital X? Sin x. Right. Here, capital X squared d capital X. For sin x, mentally put capital X and keep doing this. Then you get what, people? Here, what is this? This is now sin x. Here, add 1 to this power and divide by the new power. Minus 2 sin cube x by 3. And here, sin to the power 5x by 5 plus c. C is any constant. C is any constant. Right now, people? Right. People, another, like we did 7, another, like 7 forms we have to finish for the theories. Thereafter, more questions we have to do. And then we come to the definite integration. That is another important and very easy part. After that, we come to the application of integration. So that is the end of the lesson. Okay. All right, people. Then today I'm supposed to come to the end of the class. Do you have any doubt